Everyone. Thank you for joining our presentation today. So today we're actually going to go through a few different things. First of all, we'll start out with an introduction to Instana for those of you who are new to our company. Then we'll jump into an introduction to application perspectives. And that will wrap up the presentation material. Followed by that, we'll go into an actual demo. Steve Waterworth will take care of that demo for us, and then we'll jump into some Q&A. So don't hesitate, we'll get started. So who is Instana? Instana was founded by APM experts. These experts realized that there was a need for a new breed of APM tooling with the advent of containerized, dynamic microservices-based applications. So we were founded in 2015. We've got over 200 customers at this point. We are spread out over 20 countries from a customer perspective, and we have one very smart and very efficient robot. Just a side note, our engineering and support is based out of the USA and Germany. Now, for a young company founded in 2015, we've had very early success at some very large brands, and this is a bit unusual for a company of our age. But when you look across these companies, what we realized was all of them had one very similar thing about them. They are all developing custom software as fast as possible to create business advantage. So they've taken the methodologies that you see in green, Agile, DevOps, and CI/CD, and they've combined those methodologies with technologies and with architectures like cloud, containers, and microservices to create that speed of software delivery. Now, speed requires automation, and on the screen right now, you can see a diagram you're probably really familiar with. It is a diagram that depicts the CI/CD process. It's an infinite loop, and the purpose and the intent is to go around this loop as quickly as possible and to release high quality code into production as quickly as possible. So over the years, there have been many pieces of this methodology that have been automated. This automation is critical to going fast, and any manual steps along the way do slow you down. The big problem is that monitoring traditionally has not been automated because there haven't been the right tools in place to go ahead and automate that monitoring part of the process. So another interesting development, as DevOps methodologies have been adopted, monitoring technologies have gotten more manual because we're actually closer to the code at this point. More people who are operating these environments understand the code. And so the approach to monitoring has gotten much more manual. Now, there are vendor products that automate some of the things that you see on the screen, but there's been no tools traditionally that automate all of these different aspects to monitoring. So we add in an extra complication at this point. When you look at the rate of delivery with CI/CD, when you look at how modern applications are built, those applications have a stack that a service is built upon, and that whole stack really needs to be monitored. Now, when you add microservices into this equation where you are using CI/CD to develop and deliver very quickly, and you have lots, tens, hundreds, thousands of very small components that are being deployed on a regular basis, potentially multiple times a day or weekly, you basically develop a recipe for chaos. And what you see on the screen here is a bunch of different microservices that are all talking to each other in order to deliver business functionality. Now, the chaos is in the complexity and the management of all of these microservices that start and stop at any given point in time, and again, are being released potentially multiple times a day. So if you're relying on manual monitoring processes at all, it's really impossible to keep your monitoring up to date in this type of environment. It really takes way too much time. It's a never-ending process. You will never, ever keep up. So the core concept here is that if you do not have automated monitoring, you're going to end up with poor visibility in this type of environment. And the end result is that you will not have the speed to keep up with the competition. In the end, you'll result in unhappy customers and probably in some significant lost revenue. So how do we avoid this problem? Well, the solution is to automate monitoring. So that's what we're going to talk about today. We're going to talk about automatic application monitoring for dynamic applications. Now, what do I mean when I say automatic? Let's take a look at how Instana actually works. At the bottom of the screen is a representation of all the different components that would be servicing your applications. So with Instana, we deploy a single agent onto each host. The agent can run at the host level, or it can run as its own container. Now, as soon as that agent is deployed, it automatically discovers everything running on that host. It automatically attaches itself to what's running on that host, and it automatically starts monitoring all of those components. So again, this is all automatic. There is no configuration effort required in most cases, and we do not have the concept of plugins. So everything that we're monitoring, which is over 100 different technologies today, everything that we're monitoring is a first-class citizen and fully part of the data model within Instana. So again, that agent, it's one single agent that you deploy once per host. Once that agent is out there, it is continuously automatically discovering every technology that appears on that particular host. We automatically collect all metrics, automatically collect every trace, automatically map all dependencies, and the agent is even capable of automatically updating itself, so you don't have any maintenance to perform. Now, the ultimate goal here of our monitoring is to help you understand the user experience. Are customers having a poor user experience? Are there any errors being thrown? And so in order to do that, you need to be able to use distributed tracing techniques. And so what we do is when a user makes a request through the system, that request will flow through many different components within your architecture. And Instana is going to see it everywhere it goes and collect that data for every single user request. And the end result, back on the backend servers, in the UI of Instana, you are presented with this representation of your distributed trace. So this is a single user request. And with this information, you get to see the end-to-end response time of that user request, as well as every hop that request made through your different components and how long it took every step of the way, along with other important data related to each one of those hops that it makes. So you have all of the information that you need to understand if there is poor performance, and if so, what is the root cause of that poor performance. Now, root cause analysis is an interesting topic. That's another area where you have to use automation in these chaotic environments where we have a large number of deployments happening either daily or weekly, as well as a large number of components that we're tracing across. So you need to automate that root cause analysis, and at Instana we do that through a combination of using the very rich set of data that we have with infrastructure metrics and tracing data and dependency data. Well, we take that data and we apply AI techniques on top of that. We use techniques such as machine learning, expert knowledge, and dependency and event correlation. And that brings us to a very good idea of the root cause whenever we send out an alert. So what's on the screen right now is an actual incident that you would see inside of Instana. And this incident isn't a single event as you are probably used to in the current set of monitoring tools that exist. But this is an event that, again, rolls up many different events into one single incident. It's got the idea of a triggering event, so what actually caused the problem for the end user, as well as all of the correlated events that lead to the exact root cause of why we had this degradation. All right, so in the end, if you are going to have a highly dynamic environment and you are using CI/CD methodologies, if you're using DevOps, if you're employing microservices architectures, you absolutely have to have automation built into your monitoring platform. So this is what's going to keep you going fast. This is what's going to keep your speed up, and you can let the robot do the work. Now, automatic APM is here, right? But we've raised the bar again by introducing personalized APM with our latest feature, which is called application perspectives. So I'm going to take a few minutes to go through that, and then we'll get on with the demo. So when we asked our customers what an application was, a common response was, it's a group of services. But when we asked people what services they worked on, the answer changed based upon the product or the team that they worked on. We also took into consideration the fact that our own analytics tells us that customers are adding new services and new technologies to their environments, in some cases daily or weekly. So what happens as a new service or new technologies or new consumers are added, and what happens when dozens or hundreds of engineers are contributing to multiple applications for multiple products in these complex environments? Well, it was evident that each developer or system administrator or performance engineer or product owner or even business analysts, they all had different perspectives and they had different concepts for the systems that they use, build, manage, and monitor. And with flexibility that modern tools and automation has given us, we also understand that defining applications needs to be equally as flexible, intuitive, and fast. So let's take a look at Instana before we introduced application perspectives. So with Instana, we focus on infrastructure and services, and we collect metrics and traces out of that infrastructure and services. Well, with the advent of application perspectives, we've added in the concept of endpoints as well as the concept of applications. And this also then enables curated dashboards, performance analysis, and a personalized APM experience. So in order to understand this more fully, we're going to talk about a few different terms here. So we'll level set on terms. We'll talk through endpoints, services, calls, and applications. So what is an endpoint, right? Well, an endpoint can be some sort of parameterized HTTP request. It could be file object based. It can be some sort of database query, some sort of action, a serverless function. So think of an endpoint as something that gets called, right? And each of these endpoints has its own curated dashboard, and the performance of every endpoint is analyzed. And as you can see here, this is one of the dashboard screens that we have in Instana that you'll get a much closer look at during the demo. But let's talk a little bit about how endpoints are related to services. So what does Instana consider a service? Well, let's try and define that as simply as possible. A service to Instana is really just a grouping or a bucket of endpoints. So on the screen, you can see that we have various different endpoints that can be called. They're all part of this one single music service. Looking at the dashboard for the music service, you can see that it summarizes the performance of all of the endpoints and the requests associated within that service and provides an easy interface for analyzing and troubleshooting the performance of hotspots in real time. So here we're looking at the list of live endpoints in the music service, along with the individual performance metrics of each endpoint or route, if you're familiar with that term. You'll also notice that in the performance metrics, there's a column named calls, and that really brings us to our next term. Let's define what is a call. So a call is a logical container for all of the technical concerns of a trace. Calls have protocol specific type, they have a duration, there's a set of tags which make querying and analysis of these entities much more fast and accessible. So how are calls related to traces in Instana? Well, traces are really a set of calls that are connected together. So there's typically many calls for any single trace in a distributed transaction. So that brings us to our last term, which is applications. Applications are defined using a tag-based query engine. So you'll see how to define your apps in the demo in just a few minutes. Steve is going to show you that. Now, once you create your application perspective, the dashboards that are there will immediately provide performance data based upon those tags. And as any new services are added, that match the definition, they'll automatically join the proper application perspective. So that's the really interesting part about application perspectives, is they are dynamic and automatic as well. So as any new services come online, or any new consumers come online that match the definition of an application perspective, that application perspective is automatically updated and will never go out of date. So let's talk a little bit about this concept of personalization, and then we'll jump right into the demo. So let's say you've got multiple services in your organization and you have many different applications that take advantage of those services. You also have many different roles and employee types within your organization. And each one of those people, they've got a different perspective on what they want to see in the monitoring tool. So your SRE, they may care about the end-to-end response time and the end-to-end optimization of application A, which encompasses the services shown on the screen. So they would set up their own application perspective that matches exactly what they're looking for. The same concept holds true for a DevOps engineer. A DevOps engineer may be focused on a single service and anything coming into or going out of that service, and they want to make sure that they know everything performance-wise about that one service. So that engineer would set up their own application perspective that would show them exactly the information that they need without seeing any of the noise associated with any other services running in the environment. Same concept holds true for the developer. So a developer may want to see just the services that they write code for. And so again, they can set up an application perspective that is customized to their needs, shows only the information that they want to see, and again, cuts through all of the noise. So we described how easy it is to define your application perspectives. We made the new features really easy to use and easy to understand for everyone in your IT organization. And we've already had great feedback about how the new dashboards and analytics features really help people better understand and diagnose performance issues within their dynamic applications. So remember when we asked our customers, what is an application? Well, we figured we'd let you decide. So now it's time for the fun part, where we're going to show you a new perspective on monitoring. So Steve, go ahead and take it away.
Hi there. So if all has worked, you should see my screen. So what we have here then is the Instana dashboard, and we've started off on the infrastructure tab, and we're looking at a map of our infrastructure. So what I have here is a 5-node Kubernetes cluster, and I'm using Stan's Robot Shop, the sample microservices application available on GitHub. And I've got 2 deployments of Stan's Robot Shop in here, a production deployment and a staging deployment. And we can see, if we just zoom in a little bit, we can see then we've got various containers. So we're going back to Jim's presentation. We've installed an agent on each node or each minion in the Kubernetes cluster, and that's a daemon set, and there's a Helm chart for that. So it's really easy to get that deployed out. You can sort of do it in probably about 10 seconds. Then when that agent's running, it's going to continuously and automatically discover what's on there. So as you give Kubernetes fresh workloads or scale up, scale down, that's going to be automatically detected. When we see a technology we recognize, then we'll pick that up, start monitoring it. All that information gets indexed. So I happen to know in Stan's Robot Shop, I have a cart service that's running. So I can quickly search for it. Obviously, here in my simple demo environment, I could have just done a visual search for it. But if you appreciate, if that was scaled out to hundreds or thousands of nodes, trying to find a single service in that would be tricky if you couldn't search for it. So simple little search. And as I said, we have 2 instances there, because we have our production and our staging version of that service. So just click on that, open the dashboard up full size. This is an example then about infrastructure monitoring and giving those time series metrics. So we're looking at a Node.js application here. So we're getting all our information about the Node runtime, our event loop, and our GC activity. You'll notice at the top that we've maintained the relationships, how everything in Instana is all interconnected. We keep track of what's talking to what's running where. So we know that this Node.js app is a process on a Docker container on a particular host. And all this is linkable, so we can hop in and take a look at this Docker container. So now we've got all the time series metrics for Docker. We can see our memory and our CPU. And on the left-hand side here, we get a load of metadata about it. So we've got all our labels, all that sort of information. We're picking up all the container information. And we're running inside Kubernetes. So we've automatically detected that this container is inside Kubernetes. We're in a Kubernetes environment. So we can go and navigate and take a look at our Kubernetes. So we monitor both the Kubernetes engine itself as well as the app that's running inside it. So we get all our resource information for Kubernetes. We've got our 5 nodes here. We can see how well provisioned we are. We're quite a bit over provisioned on limits, but our requests are okay. A little tight on this one, but it's all just squeezed in there just. And then we've got all our deployments, and of course our cart is part of that deployment. So again, we can just search, and we have our 2 deployments of cart into staging and into production. Again, we can just keep following those links down, and guess what? We're back where we started. We're at the Docker container that's a process that has a process that is our Node.js app. So everything is fully interconnected. So we go back to our application. We've got our cart application here, and that application is providing a service. Hopefully you were paying attention in Jim's presentation, and you already know what a service is. So if we can, again, everything's interconnected. We can follow that link and now take a look at our service overview. So top level dashboard for a service presents summary information, and then you get more detailed information on the tabs across the top. So we've got our call throughput, our error rate, our breakdown of our latency, the top endpoints, the top traces, and then the breakdown on performance. We also have the flow map, so we can see our upstream and downstream dependencies. So shipping calls cart, which calls Redis, which calls a catalog service and a catalog database. The top endpoints, so these are the endpoints that our service has. So a service is a collection of endpoints. We get a breakdown of performance. We get a heat map of performance. So most of our performance is pretty quick for this service. And we can go to infrastructure, back to infrastructure. We won't bother going through all that again. So if we hop up to the top level here, so this is services. So this is the collection that is services. So this is where all services will end up. So any service that's discovered will end up in this list, and we can search for them. So we can search for, say, for example, for our payment service. We have a ratings service. So if you want to know where your services are, they're all in here. You can find them very quickly and easily. Now, what I just want to do is just go back to that cart service. So this is our cart service. And if you take a look at the call count, so we're looking at the last hour's worth of data. We got about 2,600 calls. If we go to our applications, so application then is a grouping of services. We'll look at our production deployment on Stan's Robot Shop. Again, for the whole application, we've got that summary screen. Then we can break it down by services. And here's our cart service. You'll notice a lot less number of calls, because application perspectives isn't just filtering. It is actually real-time analysis, because in the context of the production, so just the production cart service is called a lot less than all instances of the cart service. So all these figures are all dynamically and automatically calculated and always up to date. That's the really neat part. So if we then, whilst we're here, actually, we take a look at the configuration of this. So we obviously give it a name, and then we can add in multiple tags. So for our example here, we're just going off the Kubernetes namespace. We just go back up to the top, so I don't want to mess with this one. If we just come in here, you'll see that the number of tags that is available, there's a lot. I'm obviously not going to go through all of them, but all these tags are, a lot of them are picked up automatically, and because you can define your own custom tags as well. So back into Stan's robot shop, we've already had a look at the cart service. If we take a look at the not the catalog service, the cities service is the one I was going to use. Take a look at the cities service. Now this is a database. It's not an application runtime. This is a database, but presented in the same way. So the data is very easy to consume. You haven't got to learn different UIs for different types of service and different types of application engines. It's a consistent look and feel across. When looking at a database, the endpoints then are the tables. We have two different tables, and the performance, of course, is the SQL statements. So we can drill into just individual SQL statements and look at the runtime performance of those. So let's hop back and look at a different example of an application perspective, a different use. So now we're just looking at the payment service. So we have an application here that just consists solely of payment. We take a look there, it's just got the one service in it. So if I was an engineer responsible for this payment service, this would be my view of the world. I only care how my payment service is performing. If we go to the infrastructure tab here, we've obviously got our production and staging versions of our service. And if we're looking at our latency, we'll notice that maybe we don't want to deploy from staging into production just yet, because our staging environment seems to be running a lot slower than our production environment. So maybe got some interesting things going on there with our staging version. So this is now where we might want to dig deeper into that and now get into the traces. So we can go to analyze from here, and it's already pre-filled this in with the application name. I want to refine that a little bit further because I know it's only my staging environment that has this issue. So if I filter by my namespace, then we reduce the number of calls down, and now we're only looking at calls that are to the staging environment of my payment service. And then I get all instances of those calls. And I can drill into an example one of those and take a little look. And we can see we've got a couple of calls going out, but most of the time seems to be going here to this dispatch call. Scroll down, I get a bit more information. So now I see a full stack of what called what, in what order, where the time's been taken. And this dispatch service is one of ours. It's one of my colleagues has written this. It's nothing to do with me, but I know that we have a bit of a problem there, so I can hand that over to him, and he can start reviewing his code and find out where the time's going and hopefully fix that. But as part of this payment service, we also have another type of endpoint. We now have an external endpoint, because here we're making a call out to PayPal. So we've already looked at endpoints and services that are internal, that are application engines, ones that are data stores, and now we're going to look at an endpoint that is external. Again, everything's linked. We go take a look at that. The information is presented in exactly the same way. We have our summary information out, looking out to our payment gateway that is PayPal. And we can take a look at the performance and ensure that PayPal are actually meeting their SLA and processing our payments in a nice prompt way. And we get our performance view there of that. So that pretty much sums up a quick tour through some of the key features and the new application perspectives and services. I think we shall now go over to a little bit of Q&A, and I will be free to answer any additional questions.
All right, Steve, thanks for that. For anyone who has questions, you can go ahead and ask those questions right through the GoToWebinar control panel. So please go ahead and type your questions in there now. We do have a couple queued up already. So Steve, if you could answer this first question, it is, do I need to change my code at all to get tracing working with Instana?
Depends on the engine, on the language runtime. For some languages, it's totally zero touch. You don't need to do anything. You can take your container as you've already got it, deploy it, and we will automatically detect that, connect to it, and start monitoring it and producing traces. For other runtimes, it's just a simple additional library include. So for Node.js, for example, it's just a require of the Instana module and an npm install to bring that in, and you're good. There's nothing else you need to do. So yeah, take a look at the documentation. It'll details in there which languages are totally touchless and which ones are minimum touch.
Okay, perfect, thank you. Next question is, do I need to create any configuration at the agent level to define an application perspective?
No, all application perspective definition, that's all done in the UI. You just define them through the Create Application Perspectives dialog here.
Okay. All right, next question. Is it possible to use Instana to get uptime and downtime metrics of applications?
Yes, so we know, depends how you want to measure your uptime and downtime. So for example, we know when a container is running or isn't. So you could certainly get data out that way. You could also get it out from the fact that is it processing calls or not, but because that's dependent on whether there's anybody actually calling it. So yeah, we do know whether a runtime is there. If you've got health probes being fired, that'd be probably one of the easiest ways to check, would just be to track calls to health. If you're using Kubernetes, for example, and the health probes that Kubernetes has, you monitor that as an endpoint for each service. So yeah, there's various ways and means of getting that data.
Okay. Next question. I see in the presentation prod and staging in the same tenant. I realize that application perspectives may encompass multi-tenant support, but is it actually suggested to optimize away multiple tenants?
It's down to how you want to do it. To make a good demo, I put my prod and staging in the same Kubernetes cluster, and I'm running it in the same tenant inside Instana. You could, of course, split those out if you wanted to. I put them together so I've just got more stuff in the demo.
Okay. All right, now next question. When will this be available for on-prem installations of Instana?
That's a good question. I might need to get back to you on that once I've talked to engineering. I can't remember what the GA date for that is. I know it's imminent.
Yes, it should be very soon, but we don't have a date for you right now. As we'll go ahead and we'll follow up offline with you directly on that question. Another question. My question is, Instana needs a complement to monitoring Docker. So maybe the question is really about how Instana monitors Docker.
Yeah, well, we do. As we saw when we looked at one of the services here, I'll go back to our cart service. There's our container, and yeah, there's all our Docker information as far as that container's concerned. And we do get all the the Docker health as well. If the Docker process itself or dies or is having issues, then we're going to get that data out of it as well.
Okay, next question. What is Stan's Robot Shop, and can I use that to experiment with microservices and Kubernetes in my own environment?
Yes, you can. Stan's Robot Shop is a free open source. It's on GitHub. If you just search for under Instana, we have a space on GitHub, Instana, and it's Robot Shop underneath there, or you can go onto our website and search for Robot Shop, and you'll find some blog posts all about it and getting it running. So yeah, it's the demo app I've just been using to provide some data. So it contains a number of microservices written in a number of different language runtimes, some data backends, and a little load generation utility as well. It does have a real UI that you can log into and click about in as well if you want to do that. Yeah, all free and open source. Have a play with it in your own environment. It's designed to be small enough to run on a developer's laptop. So if you want to play with it in Kubernetes, I would suggest Minikube. I'm using Google GKE to run the demo, so I wanted to run something a bit bigger, but it will just run on a laptop.
And we had a question about application perspective definitions and using tags, a combination of tags, using and or for the combination of tags. Can you describe that a little bit? Is both and
right,
or?
Yeah, so at the moment, there's a limitation at the moment. So we could do, say, Kubernetes namespace equals whatever. But when you add another tag, I can move this quickly, just make it up as we go along. Good old foobar. You only have, at the moment, you only have the or option. The and option is coming soon. So you'll be able to build some logic up here to more have greater power over how you fine tune your selection.
Okay, great, thank you. So we also had a couple of questions that were very specific to people's own environments. We will go ahead and we'll follow up with you directly after this presentation is over. And I think that is the end of our questions. So we can take it back to Jeannie.
Thank you guys for a great presentation. And thanks to all of you for attending. Be on the lookout for the email with a link to the recording to be delivered in your inbox shortly. Have a great day.